Hi guys, welcome back to my channel Pirai Academy. In the series of Zoho interview question, today we are going to see about a question called frequencies in a limited array. You are given an array containing positive integers. The elements in the array ranges from 1 to n, where n is the size of the array, and some numbers may be repeated or absent. Your task is to count the frequency of all numbers in the range of 1 to n and return an array of size n such that result of I represents the frequency of number I 1 based indexing. So normally the array will be 0 based indexing, but here they are asking to return the result of 1 based indexing. Meaning, for example, if this is the array they have given, then result will be 0, 2, 2, 0, 1. How? What is the number of ones here? It is 0, right? So just to replace the first element as 0 because it is 1 based indexing, right? Then how many 2s are there? 2, then 3, then 4, then 5. So their number of occurrences will be replaced in this resultant array. That's it. Fine. So let us see the brute force approach for this problem. Okay, what is the brute force and simple approach for this problem? So it is guaranteed that we will be only having the elements from 1 to n, right? So I will be first taking this one and I will be traversing this whole array one time and counting how many ones are present in that array. Okay, and just replacing that in my resultant. Fine. Okay, first of all, I am just traversing this entire and checking whether how many elements are 1. Nothing. So I will be replacing this as 0. Okay, then next thing is 2. So how many 2s? 2 2s. Then how many 3s? 2 3s. Then how many 4s? 0 4s. Then how many 5s? It is only 1. Fine. So this is my resultant array. Fine. Now doing this will be resulting in time complexity of O of n square because it is up to n elements. It is up to n elements. For each and every elements, I am again traversing all n elements in that array. So which means n into n, which is equal to n square, is my time complexity. So what is my space complexity? It will be O of n because they didn't ask us the resultant array, right? So this is what? This is an auxiliary array to store all these element inside, right? Okay. So if they have asked the resultant array to return, then it will be in that case, it will be something like O of 1. But here it will be taking some space to store the count. So it will be O of n. Fine. So what is the better approach for this problem? So we can use further data structures to solve this problem, right? So what are the data structures we can use? Like hash map. We can use hash map to count the occurrences of each and every elements. So let me take an array. Okay, now I am having a hash map here. Fine. Now I am keep on traversing here. So it will be 2. So 2 will be counted as 1. Again it will be 3. So 3 is counted as 1. Now again 2. 2 is counted as 2. Then again 3. 3 is counted as 2. Then again 5. 5 is counted as 1. Now again construct the resultant. So check whether there is 1 in this hash map. No, right? So it will be 0. Now again check whether 2 is in here. Yes. So just here 2 because the count of 2 is 2, right? Again 3, yes. And then 4, no. Whether 5, yes. Fine. So this is my resultant. Now tell me what is the time complexity. The time complexity will be O of n log n because we are using a hash map here. Hash map to insert an element or to delete or just to retrieve an element from the hash map, it will be log n operation, and for n numbers it will be n log n. And what is the space complexity? It will be O of n. Fine. So this is the analysis of time complexity and space complexity for this better approach. Okay, we can also reduce this log n by taking this occurrences directly into this array. Okay, try this by yourself. If you cannot come up with the solution, just comment below. I will be giving an explanation or separate video if it is necessary, right? Okay, now we are getting into the optimized approach. Fine. So this optimized approach is quite tricky as well as it is somewhat intuitive, but you have to listen this carefully. Okay, fine. So let us continue with this. Fine. Now they are just asking us to return the occurrences, and also they have given the clue. What is the clue? It will be from 1 to n. Okay, so many of us will be just blindly go with some auxiliary space initially, right? But if you think, just think, you have a clue in every array. In every array, there is something called index, right? Okay, now I'm going to tell you how this index will be converted to an optimized approach for this problem. Fine. Okay, so they have given that it will be one based indexing in the question itself, right? Fine. So let me just decrease this all elements by 1. I will be telling you while continuing this process. First of all, let me decrease everything by 1. So it will be 1, this will be 2, this will be again 1, and this will be 2, and this will be 4. Okay, fine. Now I am just putting the index of this array. Fine. Here what I am just traversing, it is 1, right? So whatever the element I am encountering, okay, just go to that index. Just go to that index and add n to it. What is a n? N means length. What is this length? It will be 5, right? Right? So add to it. So what is the index 1? It is 2. So just add 2 plus 5, it will be 7. I will be telling you by end of this approach, you can understand this clearly. Okay, fine. Now again, traverse here. It is what? It is 7. Whether there is any index called 7? No, right? So we want to take the element from the index and mod by n. Okay, so 7 mod n. So what is the remainder? So 7 mod 5, which is equal to 2. Can you understand? We got the real answer. It is the original element present in at this current index, but we are just added 5 to it, representing that here it is occurred one time. Whenever I am adding n to any index, then it means that index element is occurred one time. If 2n is added, then it is the occurrence of that index element is 2 times. Can you understand this? Okay, so it is 2. So go to the second index and add 5. So it will become 6. Okay, now again go here. It is what? 6. So 6 mod 5, which is equal to 1. So go back to the first index and add again 5. So it will be replaced as 12. Okay, now again go here. It is what? 2. So go to 2. Okay, so 2 mod 5 is 2. That's why I'm just directly going to 2. Fine. Go to 2 and add 5. So it will become 11. Okay, now go here. It is what? 4. So go to fourth index and add just 5. Okay, just add 5 because 4 mod 5 is 4 only. Can you understand this? So directly go and add. That's it. Okay, now what is my answer? It is 1, 12, 11, 2, 9. Okay, now at last, what is the last step is, we want to just divide 5 in all the elements. Just divide 5. It will be 0. The whole division. Because 1 divided by 5 is 0 point something. So just take 0. Integer division or else. Okay. Now here it comes 2. Here it comes 2. Here it comes 0. Here it comes 1. So this is the required answer we need. Can I understand? Yes. So let me once again revise the problems. Sorry. The solution we have solved here. Okay. Now the first step for this logic is just subtract 1 from all elements. Okay, why? Because it is clearly stated that it is 1 base indexing, but our array is 0 base indexing. Okay, so subtracting 1 from all elements will be leading to 0 base indexing. Can you understand this? Fine. Now what is the second step? So the second step is just traverse the array and take the current element, okay, current index element or else current index element, and add that current index element's index value plus n. Okay, add n. for the current index element. Fine. And at last, after the whole complete iteration, what is my last step? My last step is traverse the entire array, okay, and divide every element by n. Just to divide every element by n. That's why I have just suggested that it is a tricky problem. You can easily come up with these kinds of approaches if you solved as many math problems as you can. Fine. Okay, now tell me what is the time complexity? It will be O of n because I am just traversing that array in a linear time, right? It is not inside each and every element. I am traversing another time for that all elements. Okay. Now what is my space complexity? It is O of 1 because I haven't taken any auxiliary space. I just modified the given array. That's it. Can you understand this? Fine. So this is the optimized approach. Fine. I will be showing you the code for the optimized approach. For that brute force and for that better approach, just go and search by yourself. If you can't, just comment below. I will be sharing the code. Fine. Okay. So see here, it is a Java code. Always prefer Java for Zoho. Fine. Okay. Int n is equal to arr.length. I am taking the length in my n. Then I am iterating over the all elements and just subtracting 1 from all elements. That's what I told you early, right? Now, again I will be traversing the entire array and I will be taking the index as that current index element mod n. Again, if you didn't just listen the drawing explanation, just go once again and listen that entire lecture and come back to this coding path. Okay. Now, ARR of index plus is equal to n. Just I am adding the value to the index element. Okay. Now again, I am again traversing the entire array and dividing n on all the elements. Fine. Now just return the modified array. Can you understand this? Let me submit it. So here the error is that the return type is list of integers. But I have written what? The integer array. Can you understand this? So it is not a major problem while you are solving in Zoho interviews, because in Zoho interviews they don't give the return type and parameters. They only say the problem statement and you want to write the entire code. Okay. In that cases, this will be the optimized solution. But hats off, now here they are asking the return type as list of integers. I want to just create a list of integers here and take the all array elements into that list of integers. Okay, so this will be leading to a auxiliary space and it will be resulting in a space complexity of O of n. But in real time, when you are building from the scratch, you can be returning just the array. In real time, you will be printing the elements, right? So in that cases, you can just print that array elements. So there will be no space complexity and it will be the optimized solution. Okay, here let us see the change. So yes, it is the modified code. So here I am just converting the array into a list of integers. But it is not necessary when you are seeing the C++. See here they have given the vector of int and they are also asking the result as a vector of int. Okay, in that case, you don't want to do any conversion and there the space complexity will be O of 1. Can you understand this? So based on our problem statement, we are just modified here a little. Okay, but to make sure, I just want you to go with this approach because this is the more optimized approach. Fine. So let me submit it. Yes. It is submitted successfully. To know about these kinds of algorithm, just go and watch my YouTube channel. And if you really like this video and subscribe to my channel. Watch the entire playlist on this Zoho interview question to know well about this round. Fine. Thank you.